Here we're given this differential equation and we want to sketch the slope field at the 8 points indicated. So this is a throwback review. So we know our slope equals 0 when y equals -1. So down here at these 2 points where y is -1, we'll have a slope field of 0. So we know our slope equals 1 over x when y equals 0. So here at 1, it's going to be 1 over 1, which is 1. Here at -1, it's going to be -1 over -1, which is -1. So those should be reflections. Here at 2, it should be 1 over 2, which should be less steep than 1. And here, this should be -1/2, which is less steep than -1, reflections. Last but not least, we know our slope equals 2 over x when y equals 1. So here at 1, it's 2 over 1, which is 2, which should be more steep than 1. And this will be -2. -2, more steep than -1. Now we want to find a particular solution to the differential equation with the initial condition and state the domain. So we are given this implicit differential equation. We're going to solve it by separating variables. So here are our terms with y, and here are our terms with x. Separating these variables, we have the integral of dy over 1 plus y equals the integral of dx over x. So antiderivative of the left is ln absolute value 1 plus y plus c1 equals ln absolute value of x plus c2. Isolating or consolidating our constants, I have ln of 1 plus y absolute value equals ln absolute value of x plus c3. So now we need to use this initial condition in order to solve for c3. When x is -1, y is 1. So we have ln absolute value of 2 is ln absolute value of -1 plus c3. ln of 1 is 0, so ln 2 is c3. Going back to our equation, ln absolute value 1 plus y equals ln absolute value of x plus ln absolute value of 2. In order to solve for y, I'm going to exponentiate both sides. E to the ln cancels, and we're left with 1 plus y equals. Now remember, if we're adding our exponents, that's actually means that we're multiplying exponents with the same base. So that means e to the ln absolute value of x times e to the ln absolute value of 2. Both of these e's to the ln's cancel out to make 1 plus y equals 2 absolute value of x. Isolating y equals 2 absolute value of x minus 1. Now remember, they want us to state the domain. So this this absolute value function actually splits into 2 pieces. 2x minus 1 for when x is greater than or equal to 0, and -2x minus 1 for when x is less than 0. So which piece are we going to use? we have to look at the initial value, initial condition, and we have to note that we have negative x values. So that means we're only going to focus on the bottom piece, y equals negative 2x minus 1 for when x is less than 0. So we might want to actually cancel that out to show that we're only focusing on the bottom piece where x values are negative because our initial condition came from a negative x value.